Think math.
Take a right triangle, use one of its legs as an axis, and spin it. It was a flat triangle a moment ago, and now a smooth cone stands there. Spin a rectangle and you get a cylinder. Spin a semicircle and you get a ball. How does one flat shape turn into something so different? Follow a single point and it becomes obvious. Pick one point of the shape and turn it about the axis, and that point traces a circle whose radius is its own distance from the axis. Points near the axis trace small circles, points far away trace big ones. A solid of revolution is nothing but those circles stacked together. That leaves only one thing deciding the outline. At each height, how far is the shape from the axis? That number is the radius at that height. So the edge of the flat shape is really a table of radii. Read how that number changes as you go up, and you know in advance what will appear. Put 3 of them side by side. A rectangle keeps the same distance at every height, so it has the same thickness top to bottom, which is a cylinder. A right triangle's distance falls off in a straight line and meets at a point, which is a cone. A semicircle is farthest at the middle and closer at the top and bottom, so it bulges into a ball. The same shape gives something else if you change the axis. Spin the right triangle about its base and you get a wide, low cone. Spin it about its height instead and you get a narrow, tall one. The shape has not changed, but the distances to the axis have. Choosing the axis is half the answer. So, a solid of revolution is a stack of the circles each point traces. The distance to the axis at each height is the radius at that height. And how that distance changes is what separates a cylinder from a cone from a ball. Next time, what is hiding in the cross-sections when you cut one of these open? See you in the next one. A sip of math every day here at Think Math.